exit. Good afternoon everyone, I'm Abdul Muiz, and today my team and I are going to walk you through what we think homes are going to be for the average consumer in the hopefully not too distant future. So without any further ado, let's get right to it. First up, we have a laser pointing at an LDR followed by a sonar. Now these two components are going to help us determine when a person leaves or enters the room. Now you could argue, why not just use one of these components, since either of these could be used as methods of detection? Well, the answer to that question is we simply wouldn't be able to differentiate an entry from an exit, and it is imperative that we are able to do so. So during an entry, the laser is blocked by the person entering, and the LDR's value drastically changes. As the person moves forward, the sonar's value changes. Now, the order in which this happens is important because during an exit, the opposite happens, meaning that the sonar's value first changes, followed by the LDRs. Now, we are also keeping a counter to be able to know when the room is fully empty or not. So when there is one or more than one person in the room and someone else enters, there is going to be no changes in the fans and the lights department whatsoever. Only when the room is fully empty are the lights and the fans going to be turned off. So here's a quick demo. As you can see from the serial monitor, currently there are 0 people in the room. Now as we bring the person over, and as soon as the person enters the room, the fans and the lights, they all turn on. Consequently, the counter records that, which is denoted by people, and the value becomes 1. Here's another look at it. Likewise, an entry is registered, and the counter increases by 1 to 2. Now we've also incorporated an LDR into the system that, depending on whether there is ample ambient lighting or not, turns the lights on or off. Here we're using a paper cover to demonstrate that. So as soon as we take the cover off, the lights go out. Now here's a demo of an exit. Accordingly, the count goes down to 1, but since according to the system, there's still one more person in the room, the appliances are still on. Now for demonstration purposes, we're putting the cover back on again. Anyways, exiting once more reduces the count to 0, and everything is turned off since there is no one in the room anymore. So that was a quick demo of our setup.
Hello everyone, I am Shirley Roy. Today I am here to talk about the experimental setup of our project. So to run this project, we used Arduino UNO as our microcontroller. Here is 14 digital pin and 6 analog pin. We connected all the components of our project with this Arduino and powered it on with a 8-volt battery. Then it just occupied all our automation systems. Then we used this sonar. This is SMC-R04. We use this sonar to detect whether a person is coming or leaving the room. When the number of people in the room becomes 0, this sonar just sends its signal to Arduino, and the Arduino turn off all the appliances in the room. Then we use this push button to help the owner. If owner wants to turn on or off the fan or light manually, he can use this push button. The main task of this push button is to toggle the current position of light. Then we used DC motor. DC motor is this is a sample model. We use the DC motor to rotate the fan. Actually, this converts the electrical energy to mechanical energy and then helps to rotate the fan. Thank you all.
Hello everyone, my name is Nadib Hussain, and we also use potentiometer. If someone wants to manually reduce the speed of the fan and the brightness of the light, they can use potentiometer. And we actually use Arduino UNO in our project, but the output of Arduino UNO is only 5 volt, and to run a motor, 5 volt is not enough. That is why we use motor driver. With motor driver, we can control the value of the motor, and at the same time we can use outside DC source through which we can run the motor.
Hello everyone, this is Wakas Iqbal. Well, I know you have many questions hovering over your head, one of them being the possibility of the user wanting to switch on or switch off the light that doesn't quite meet the conditions set by the LDR. Say for instance, you lost your keys, or some keys fell off your hand and you can't find it out or you cannot reach it. In such situations you might need the help of extra light, right? So if during the daytime there is no light because you do not require light, that wouldn't be enough sometimes. So we took care of that quite well. We have a push button for it. The user can manually instruct the light to be switched on or off without the intervention of the sensors. Moreover, we have a temperature sensor, the LM35 temperature sensor, which determines the temperature inside the house. Our system not only keeps the lights off during daytime, but it also keeps the fan off when it's cold enough. So how much is enough, right? So for temperature of less than 18 degrees centigrade, the fan is at rest. We hard-coded it into the Arduino IDE. One of the things that we initially considered to use was a Bluetooth module, but however we did not follow through it because of its strong limitations. The range of Bluetooth is very short, and in real life applications we did not find it something to be very appealing or like very working. Well, to conclude, I would say our setup aims to add value to the user and saves time of those who are chronically busy. In this day and age, everyone wants to save and reduce energy consumption, and conserving energy is the first thing you can do for the environment and for your pockets too. That's all. Thank you for watching.